Hey everybody, welcome back to the Brick Breaker project for grade 12 computers. Where we left off last time was that we essentially just have a paddle and a ball, and the ball is still bouncing off the paddle at the direction that it came in, which we don't really want. We want, if we're off the left edge, for the ball to bounce that way. If we hit the right edge here, we want the ball to bounce off in the right. If we hit the middle, we want the ball to bounce up. So we essentially want it to bounce at some angle dependent on its distance from the center of the paddle, right? If it's hitting the center of the paddle, it should go straight up. And anywhere to the right, it should go right, depending on how far. We may even want to play with that angle, so that if we hit the very far right of the paddle, it bounces much more to the right, and so on and so forth. So that'll be our goal today. Last time we limited the speed, and we did that in the ball class. We also made a check collision, which we're going to use today. Okay, so why don't let's just think about where we want to put the code for the ball bouncing. I think we could potentially put it in the paddle class. We could also, we have this check collision function. We could even put it in the return true. Before it returns true, we could just put some code in here to have the ball bounce, to change its angle a little bit. Right, there's our angle right there. So maybe we want to do it that way. And I think that should actually be a good way to do it, because this check collision function is only checking if it hits a paddle, because we pass it a paddle. So any code we put in here after we return true, before we return true rather, returning true just quits the whole function, right? So we want to put some code in here to bounce ball off at an angle. So maybe let's just draw what we want to do here. So here is a little drawing that I'm going to make. Hopefully there's my paddle. Pretty useless with this notepad that I have. It's just like feels weird to draw on it, but Box2D is going to reference it from its center, right? And I think we do as well, hopefully, with our paddle class. Let's just check if we do. Yes, we do, because we, when we set the origin of the thing, we set it to its width divided by 2 and height divided by 2. So this is going to be kind of the px, the paddle x, and py, right? And all we want to do is measure the distance. So if the ball hits here, right? And the ball is measured from its center, which is bx and by. We just want to set our angle to be we want it to basically be straight up and down, right? If the ball's x position minus the paddle's x position equals 0. I guess I'll put 2 equals there, right? Because then they have the exact same x position, so that should be bouncing straight up. If the ball's position is greater than the paddle's position, we want it to bounce off to the right. And if the ball's position is less than the paddle's position, meaning it's over to the left somewhere, we want it to bounce off to the left. So that's our goal, and maybe we want to do it based on how far away it is. It's not going to be that tricky to do. If we go to our ball class and we say something like, now I guess we could take their SFML positions, because ball and paddle are both SFML drawings. So let's just see out for now what the ball, now I'm on the ball class, so I would write this dot get position, and get position, does it return a vector 2f? Of course it does. Dot x subtract, not this dot get position, but my paddle, which is p1, the one that the function knows about. So I'll go p1 dot get position like that dot x, and that should spit out excuse me, that should spit out the number of pixels that they are apart, the ball's position and the paddle's position in the x direction. So let's run that. Let's see if we can get them to hit. Let's see if we can get it to hit kind of near the center, and we should hopefully see a very small number. If we're lucky, we may even get 0. It didn't work. Why is that? It's because I didn't call the function check collision. Okay, so I'm going to do that now. I did it here last time with a cout. I don't want to do a cout now because it'll print out the number 1 when they hit and 0 when they don't. So I'll just call check collision, and it won't cout anything unless there is a hit there, hopefully. So I'm going to try to hit it kind of close to the center again. And it was only 4 pixels to the right of the center of the paddle. Now if I go to the left edge, it's 39 pixels to the left of the paddle. And if I do the right edge, it looks like it's like minus 68. How big is my paddle in width when I went to make it? I said that my paddle was 150 pixels wide. So again, looking at my paddle here, this is going to be minus 75 is the farthest it can really hit, and plus 75 is the farthest it can hit on the right for my paddle's x position, right? Px, and Px is minus 75. So let's say I take Bx minus Px, and I want it to be, I'm going to times it by that distance. So I'm going to take my angle and times it by that distance, and maybe say, the steepest angle that I can have will be something like 45 degrees or something. So let's go back here and say, okay, well, the biggest number this can be is 75, and the smallest number it can be is minus 75. So I'm just going to divide this by 75, right, like that. I could also, if I want to be proactive about it, and my paddle may change later on in my game, right, I don't have a variable here for the width and the height of my my paddle. So why don't I make a couple of variables, a float, we'll call it W, and a float called H. You could do it that way. I would actually prefer to maybe call these W and this H to be more consistent with the numbers I gave. This is my constructor, remember, so the person's going to type in a width and a height in the main file when they make one. So they typed 150 and 20. So if I go back to my paddle and I make a variable called width that will always be kept track of, and a variable called height that will always be kept track of, then here I can say width equals W, so whatever the person types in, my variable will equal that. And for height, I will let that equal h. So whatever they typed in 20, so my height is 20. And now I have that to keep track of. Let's just run that, make sure there's no errors. Looks all good to me. We have a hit. Look at that. It actually gave me the number, if I hit the dead edge of this thing, like right on the right, it should give me a number of 1, right? And the thing is, it's bouncing really weird now because I hit the side of it, but let me just run it again and see if I can get it to do that. And it gave me a number closer to 0 because it hit closer to the center. It was still positive, so it was a little bit right of center. There's a little bit left of center. So I'm aiming to have a number between 1 and -1 depending on where I hit in this paddle. I had a number a bit bigger than 1 because I hit the left edge of it, but that's okay because that would cause a game over anyways usually. So let's see if I kind of can hit either the left or the right edge and see if I get a number close to 1. There it is, yeah, -1. It's even a little bit bigger than -1, but that's going to be okay. There's 0.83. I've kind of affected it by hitting the corners. Okay, so this is cool. I've got basically, if I hit the middle of the paddle, there's my little mouse here, I get a number of 1. If I hit the right edge, I get a number of +1 and -1. So if I can just take that number and times it by like 45 degrees, for instance, then it will just bounce off at 45 at the most and -45 at the most, and it'll bounce straight up at 0. The one thing I did say I wanted to do was be proactive about putting 75 here. I would rather put the width of the paddle, so p1.width. Will that work? Yes. And then I have to take that number and divide it by 2 because I want half the width. And I'll do that in brackets. Let's see if that gives me the same thing without any crashes here. Yeah, it did. It gave me a number of 1 when I hit the right edge. And let's see if I can hit them. Yeah, it looks like it's fine still. I'm going to try to hit the left edge. It might be difficult here. Nope, it still gives me -1. So great. This number here is always a number between essentially -1 and +1. Okay, so what I'll do is I'll just set my angle to this number. Copy. I'll set angle equal to that. I still have that angle thing, so I'll paste all that. I don't need to see out it anymore for now. Maybe I will if I get into trouble and it doesn't work, but for now I'll just have the angle equal that. And then I gotta take this whole thing and times it by, forgot a bracket there, by the way. So I'm going to take this whole thing, and originally I wanted to times it by 45 degrees, right? But that's obviously going to be an issue because that is in degrees. Box2D likes radians. So that might be a little bit of an issue, although we took care of it here by setting, when we created the ball, by setting its linear velocity. And then, so I'm just going to actually steal this code. Okay, and paste it there so that once my angle is set, I just want to reset the linear velocity of my ball to the speed, which is always constant, and the new angle that I found. The only problem is in Box2D, down is up and up is down, right? So this is actually -45 degrees. I think it is. This is actually -90, and this is actually -135. I'm pretty sure that's right. So if I'm going to times these numbers by 45, I'm going to get 45 degrees here. I'm going to get 0 degrees here, and I'm going to get -45. So whatever angle I get, I actually have to subtract 90 from it. Because if I have 45 and I want to get to -45, I actually have to, whatever angle I get here, I need to take 90 degrees away from it. So hopefully that'll work for us. Let's test it out. I don't have a ton of hope here, but I'm just going to subtract 90 degrees and see if my paddle bounces nicely. Let's give it a chance to line up and hit somewhere good. I'll try to hit the center and see if it goes straight up first. Yeah, it looks like it did work. If I hit the left edge, does it go left? Yeah, great. It actually does work, so that is a miracle. And then it goes to the right when it hits the right of the paddle, so it bounces off in the opposite direction. It allows you to steer the ball a little bit more, which I think is important in a brick breaker game, or else the game is really boring. If you don't like 45 degrees, I think that it might not be steep enough, right? So I'm going to maybe try 60 degrees or even 70 or something. And then it should bounce a little bit steeper without affecting the center point. So center is still kind of straight up and down, but now it's just bouncing a little harsher on the left and right edges, which is good for a brick breaker game because then you can really aim it. So that's what I wanted to cover in this lesson. And hopefully that can help you add some more dynamics to your game. Let me know if you have any questions or anything like that in the comments, or if you need me to help you too on your computer at home, I can do that through Zoom or whatever too. So I know that it's hard to code a project like this without that you would normally have spent like 5 hours every week with the teacher, right? So I don't expect you to make like the most amazing project you could have made if you were in class every day, but try it out. I think it's definitely a cool project in C++ and a good use of Box2D with SFML, and also a good way to learn about classes and structures and making your own objects and stuff too, and using other people's libraries as well, right? Like tying in Box2D and SFML. This isn't normally something you would learn in a high school class, but it's definitely going to give you an advantage if you go to university for this stuff. So just wanted to show you that. We'll add some bricks the next day and maybe a power up or two. You can see that it's pretty easy now that I've compartmentalized all my code. If I want my paddle to get bigger, you know, at the end of the day, I would probably say something like paddles, make a function called paddle size. And I can't spell right now, but if the person will type in a size or something like that, and I'll make the paddle bigger, and it'll just get called depending on what happens in your game. Maybe something falls from the screen in the main, you detect that collision happens, and then you just call main paddle dot update size or something or whatever, right? We'll get into that a little more next week. Okay, so stay tuned for that. Thanks for watching. Talk to you soon.